All right, so welcome back. Welcome back to this channel. So, I'm very sorry for the bad setup here, but I know maybe thought maybe we could just do this video very fastly. So I have actually decided I have actually thought to make this video like yesterday, but due to some like power reasons and all that, I couldn't able to. So in this video, as you have seen in the thumbnail and the title and the like the title, we are going to introduce I think basically we are in this video we are going to learn like about llama, of course, but on a very uh, high level manner, because we are not going to go into deep, because a lot of concepts, I think there are many NLP concepts, so there is no drastic change that have been made only for this model. So I think most of the changes, most of the architectural changes that are done in this model are actually pretty common and have been done in other models such as GPT and all that. We'll be going through that. So most of the important topics, the important changes, I think I'll cover them in the future videos. So this is essentially, so this video is essentially, before getting into this video, I want you to take this video as an introduction to like better language modeling, right? Llama. So, and then we're also going to look at how we can actually pre-train Llama, right? How we can pre-train or fine-tune, not pre-training, sorry, not pre-training. We are going to how we can fine-tune Llama model to solve your own problem on your own data set, right? We have a lot of data sets on Hugging Face, so we'll be using some one of those data set to fine-tune this model for our own purpose, and no matter what, it doesn't matter what your purpose actually is, right? So this is the paper, Llama, Open and Efficient Foundation Language Models. So it's a very, I think it is, of course, it is created by Meta AI, Facebook, right? It is released on 27 February this year, 2023. So a pretty new paper. So I'll be covering that. What is this paper actually shows. So yeah, so they have trained language models. So they have trained many language models with some architectural changes, which we'll be covering in the future videos. Not this video especially, but in the future videos, I'll be releasing. I'll try to release video like one video every day. I'll try to, and maybe we'll just go through that. Like I have, yeah, I'll probably try to release like one video every day, covering all the important NLP topics. So I thought this is the nice time. This is a very good time for us to actually learn about NLP. So over the past few videos, we have been learning a lot about like uh, image generation models and all that. So we'll be coming back to NLP, and we're going to discuss the main topics, the main models that have been released. So let's get started. So one main statement that might like really impress you is like the Llama 13 billion parameter model outperforms GPT-3 with like 175 billion parameters on most benchmarks. Right? So Llama 13 billion parameter model outperforms GPT-3 175 billion parameter model on most benchmarks, which is actually, I think, a pretty good achievement. And Llama 65 billion parameters is competitive with the best models, like I think Chinchilla 70 billion parameter model and Palm 540 billion parameter model. So it's a very good accomplishment by Llama. They have outperformed GPT-3, not GPT 3.5, but GPT-3 by a lot of on most benchmarks, with only like 13 billion parameters, which is a very good, which is a very good achievement. As you can see, despite being 10 times smaller, they have outperformed GPT-3. And so in the rest of the paper, they present an overall overview of the modifications we made to the transformer architecture. So again, on the base transformer architecture, which we have discussed in the last one of the past few videos about the transformer architecture, right? So they have made some changes on that transformer architecture, which we are going to discuss. So I'll just be like this, get down. So our training approach is similar to the most methods described in previous works, right? So as I've told you, they haven't actually built their own method or something, but they are using like other methods that are already in the field. So they just use those methods, and let's just go down. So these are the sources from which they have extracted their pre-training data. So first of all, remember that this model, you can actually fine tune this model for your own data set, which is actually a very good thing. Yeah, right. You could have like so this model is actually trained on huge amounts of data, pre-trained it. It is pre-trained on like huge data. So what you could do is, you could just um like you could just take that pre-trained model and pre-trained knowledge, so it has a lot of knowledge on the like the real world data, how the text looks like, and how like text, different relationships, different attentions, and all that. So it knows a lot about text, especially considering that it is a very large model, right? And then you could use that pre-trained knowledge on different tasks, like on solving different tasks that are related to text, right? So that is the idea of pre-training it. So the model is pre-trained. So the model is pre-trained on bunch of sources, and 67%. So 67% of the pre-training data has come from English Common Crawl. I think it is a collection of like I think it's a collection of English pages and all that, English text. Probably like a pipeline or something, right? And then they have collected the other data from like C4 data sets, 15%, and they have collected 4.5% of the data from GitHub, probably code, right? Most probably code. And then the other 4.5% of the data has been collected from Wikipedia, right? A lot of pages, I believe, right? And also Gutenberg and books, 4.5%. Arxiv from Arxiv website. It contains like Arxiv contains a lot of research papers and a lot of scientific data, right? Or like different fields, even machine learning and deep learning, right? So they have covered like they have collected 2.5% data from Arxiv and like Stack Exchange. I think probably answering questions and all that. Question answers 2% of the data. And so that is the main data sources from which they have collected their data, right? And then the tokenizer they'll be using is they'll be using like byte pair encoding, which we will cover in the future. So don't worry, right? So we split all numbers into individual digits and fall back to bytes to compose unknown UTF-8 characters. And then the architecture changes. Coming to the architectural changes, the following recent work on language models. So they have, as you know, there has been like lot of work going in large language models, especially because of GPT 3.5 or ChatGPT. Right, our network is based on the transformer architecture. We leverage various improvements that were subsequently proposed and used in different models such as PALM. Here are the main difference with the original architecture and where we were found the inspiration for this change. So again, as I have said, they haven't made like some main differences. So they have essentially like inspired from some other models. So for example, they have used like pre-normalization technique. So like they'll just normalize the data before inputting it for like each sub layer, like each transformer layer. They'll just pre-normalize the data before like processing. So they have got this technique. So this technique was actually inspired from GPT-3. So the GPT-3 model uses the same technique, right? They'll use like RMS norm normalizing function, right, to actually normalize the input before sending into the transformer layer. And then I think they'll just use replace the ReLU activation function with SWIGLU, SWIGLU. I don't know if I could pronounce it like that. That is probably a very wrong pronunciation, but SWIGLU activation function, and it is inspired from POM. Again, we'll cover this. I think I'll make separate video for this activation function, what it actually is, maybe mathematical derivation and all that. Even I have to like go through the paper or something, right? So it is introduced by I think Shazir at 2020 to improve the performance, right? And then they'll use rotatory embeddings. I'll also make a video on this. We remove the absolute positional embeddings, we remove the absolute positional embeddings and instant and add rotatory positional embeddings introduced by uh, at each layer of the network. So I think I don't know if this is like a name or not, but I think so. The main idea is they'll be removing the positional embeddings right before like passing the data to the transformer block. We'll be having like adding positional embeddings to make the model aware of the positions of each text of each word, because we are not solving the problem using like sequence modeling in transformer. So we'll be adding positional embeddings uh, before actually passing the inputs to the transformer model. So I think they'll just replace them with rotatory positional embeddings, which we will cover in probably the future videos. And coming to the like optimizer, they'll be using the Adam W optimizer, in which we are going to have like a bunch of extra parameters. I think that's all I can say. So they'll be having like bunch of extra parameters that will be updated during the gradient descent. Again, as I've told you, we'll cover all the changes in the future videos, because I think it is good. It is good for us to actually go through the model on a very high level, because before going into the depths of it. And then they have also made another change, right? We have a section here called efficient implementation, in which they will be like to in order to reduce memory usage in runtime. Again, as you have shown previously, before I think a minute or two, that this model performs better despite its lesser lesser parameters, and also it is pretty fast, right? So therefore they will be they have used some techniques in order to reduce memory usage in runtime, right? So they'll be using something called X formulas, right? which will uh, which will definitely cover. And um and will to further improve training efficiency, we reduce the amount of activations that are recomputed during the backward pass with checkpointing. More precisely, we save the activations that are expensive to compute, such as the outputs of linear layers. This is achieved by manually implementing the backward function for the transformer layer instead of relying on Python AutoGrad right, to fully benefit from the. Okay, so essentially, they like skip the expensive activation function, I think. So they'll just implement a backward function by their own, rather than like using like the PyTorch AutoGrad function, right? So they'll reduce the amount of activations that are recomputed during the backward pass. So during the backward pass, they'll just reduce the amount of activations they have to compute. By that, they'll just implement another I think separate backward function in order to do that. And like these are the main changes. And again, as you can see, there are like many sections. It could be used for like mathematical reasoning, closed book question answering, code generation, just like even ChatGPT could do that. And massive multitask language understanding language over multiple tasks, and evaluation of performance during training, and all that. And also from like safety, bias, toxicity, and mixed information. And yeah, so I think this is the paper, the main thing of the paper, the very high level overview. I know. Now I think it is time for us to just play around with this model. Let's just to like understand how to fine tune it. So in this tutorial, in this notebook, what we are going to do is we are going to take the LLAMA 2 pre-trained LLAMA 2 model. So we have the pre-trained or LLAMA 2 model, and then we'll be using this pre-trained LLAMA 2 to actually fine tune it for a different problem, for a like a chat, like essentially like a chatbot problem, right? For a different problem. I think I'll just show you the data set. I'll show you the data set. I'll just copy it. And the data set is actually quite weird, because it is not only in English, but also it contains different languages, which is pretty interesting. Right? I think this model is also trained on different languages. Maybe it is trained on different languages. Um, so as you can see here, so this is going to be the data. I'll just show you. So this is like each sentence or each row or each pair. So this is the, I think, the question and answer. So it is going to contain a question and answer, right? So I don't know what language this is. So this is English. So I think, yeah, it consists of like bunch of like inputs and answers, just like chatbot. So this data set contains of input and answers. So as you can see, compose a professional email with the following points: me, Chinese cook, 10 years, good cook, people love my food, can you hire me? So, and also, and so this is the question and this is the response. Thanks for the information. So this is the response the model has to generate. Unfortunately, your initial message does not contain enough details or structure to compose a compelling professional email to a professional empire. So again, so as you can see here, this data set contains of like question answer pairs and over different languages, which is actually pretty good. And as you can see, we have English, one more, and I think Chinese maybe. And different languages. I think the model is actually trained on different languages. Let me search if Llama 2 is actually trained on different languages. I think maybe it is trained on many languages. So yeah, about 90% of the training data was in English, with roughly 9% in unknown languages. Okay, so only like 9% of the model is actually other languages. I think 90% was in English. Um, Yeah. So this innovator model is capable of fluently comprehending and producing content in a various variety of languages. So therefore, we are safe. So the model could perform on this data set also. Then the model could understand different languages, which provides a very good starting point for us. Right? It is a very good starting point for us that the model that we could be confident, maybe at least to some extent, that the model could understand what this text actually means. So I think we'll get to the notebook. I'll just make sure you use like the GPU, right? Make sure to go like click on runtime. If you are running this on Colab, if you are rich and if you have our own like GPU, then you can just use it. So you can just make sure like if you are using like the free Google Colab service, and just make sure you are using the GPU T4 GPU. Click on save, run the first cell. So we'll essentially be like, yeah, I think installing like the transformer model and also the data set through which we will load the data set. And then right, so I'll just make sure it runs. And so this is second cell. So we'll just import like the load data set. So we'll just import load data sets from this data sets library. So I'll just say from data sets import load data set. And then this is the data set name. This is the name of the data set. So if we just search it on Google, you'll have this link. So it actually very a relatively big data set. It is a pretty big data set. Yeah. So it is like many pairs. So I'll just load it up. So we'll just load the data set. And if we if we just say data set text, so this data set actually contains like all of the pairs like combined together in like one string. So if you just open this, you'll have like one string containing like all the data. I think all the data. Probably not all data. Right. So let's just see if we have English in there, middle, maybe. Oh yeah. Yeah. So we have English in the middle. So so we can just see, look at the data yourself, what that is, what that look like. And now we can actually import the models that we'll be using, right? So we'll be using this auto model for casual LM. I think for so this is for like the language model we'll be using the LLM llama that will be using to fine tune, right? And so I'll just run this. So this is the model name, the name of the model that we'll be needing, llama 2, 7 billion parameters, right? So we'll just pass in the model name, right? And then so don't worry about the other details here, like the bits and bytes configuration, and a bunch of parameters. Will that they're not actually very important. The main thing for us to actually learn the main part, which is fine tuning the model and what the models actually are. I'll probably cover them in the future videos what these things are. But again, uh, I know I'm thinking of starting like a big series in which I cover like main topics of NLP, language modeling, the new papers uh, which have been published recently. I'll probably cover them as we go on. So, so the model is actually creating. It is loading a model. Uh, Meanwhile, we'll just open this. So here we'll just get the tokenizer. So we also have like a tokenizer specific for this model. So each model is going to have like its own tokenizer. So we'll have this model's tokenizer, like based on like how we tokenize each text, the numbers essentially for each word. And because the model is actually trained on multiple languages, it could understand languages, and it could like give a specific name or specific let or number for each of these words. We'll on that. Right, it is running. So yeah, it might take some time. Don't worry. And then next cell. So we'll essentially like using the like creating the like the optimizer. We'll be specifying the dropout, the alpha value for the optimizer, right? I'll run that also. And then here we'll be importing training arguments. We are going to give some arguments. We are going to save some arguments like where the output actually should be stored. So the output will be stored at this results folder. And then this is the optimizer, the number of steps, the learning rate, the max steps, the learning scheduler type, which is constant. And we have like all these parameters important in this training argument function. We'll be importing the output directory in which we are going to save them the model files, the optimizer, the number of steps, the learning rate, and bunch of things. So I'll run that. And then finally, we could build a trainer function using this SFT trainer model from TRL. So you can just say from TRL import SFT trainer and just specify the max sequence length, like what you want the max sequence length to be of each sequence. And then we'll input the model that we have already created. We have created, I think, an attribute of like auto model for classful LM. We have called we have called the llama 2 model from that library, and we have created a like an object. We'll be passing that to this parameter. We'll be passing the data set which we have collected again. We're going to pass the bunch of configurations and also the field that we are dealing with text data. We're going to pass the tokenizer and the training arguments that we have created. I'll run that. And then right, so we'll keep running that, and I'll run this. So here, right, we'll just loop through all of the modules we have in this trainer, and then essentially we'll just convert all of these like normalized values into like float digits. We'll just make sure that all data is actually float values. So float 32, we'll convert them into float 32, and we could run the trainer.train to train the model. Right, we'll just run that, and then it might take some time. I think I'll see you after training. So yeah, let's pause it. I'll pause the recording and I'll see you after training. All right, so we have the training is finished, right? So when you run like this cell, you will be asked for an API key from weights and biases. So if you don't know weights and biases, well, it's a company where like you could access to you get access to different models and train different models. So if you run this, you'll be asked for a API key and you'll be provided a link. So just click on that link and just use your Google account to log in or sign up. It's very pretty simple, right? Click on sign up and it'll open a bar. Uh, Login through what? Click on login through Google and select your account. And log in through a Google account, and then you'll get an API key. Copy that and paste it here and run it. And after some time, it may take a lot of time. Don't worry, but after some time, you'll just get this model. So it actually performing very good, pretty good. So yeah, with some very good training loss and all that, or we work, and you could actually run it and use it. Right, you could actually run this model and use this model for your own purposes, right? For your own purposes, whatever your purpose is. And like this, you could train this language like llama model to whatever data set you want. You could find whatever data set online and you could actually find your model. So that is llama 2 fine tuning, and that is the basic introduction to llama 2. So thanks for watching. In the next video, hopefully in the next few videos, we are going to go through some NLP techniques, language model techniques. So please stay tuned. So thanks for watching. I'll see you in the next video.